Hi everyone, welcome to the 4th grade Enhanced Math Week 5 Division with a 2-digit divisor solution video. Let's start right off with problem 1. Use long division to compute the following problems. Let's start right off with number 1, 78 divided by 20. Right away, we know that 78 is going to be your dividend because that's the number that's being divided. And then 20 is going to be your divisor because that's the number that you're dividing by. But how do we do this with vertical method? Well, let's set the problem up like this. The dividend always goes inside and the divisor goes outside. And now we're being asked, how many times does 78 or how many times does 20 go into 78? And we know that the largest number that is a multiple of 20 that doesn't go over 78 would be 60, right? And how many 20s are in 60? We know that's 3. And then we put 60 down here below because that's the largest multiple of 20 that we can get to without going over 78. And now we subtract these two numbers to get the remainder. 78 minus 60, that gives us 18. And since 18 is smaller than 20, we cannot divide further, which means that the answer is 3 with remainder 18. The R represents remainder. So this is your answer for number 1. Number 2, 221 divided by 32. Again, the dividend goes inside and the divisor goes outside. And this time we have to see how many times does 32 go into 221 without going over. And we see here quickly that 6 times 32 is going to be the largest amount that you can get to 221 without going over. And this quickly gives us 192. Why 992? Because we multiply it by 6. 192. And then you subtract 221 by 192 and you get 29. And you see here that again, 29 is smaller than 32, which means that we cannot divide further, and the answer is 6 with remainder 29. So these are your two answers for 1 and 2 so far. And now let's erase this board so we have a fresh canvas to work with, where we're given problem 3, 453 divided by 40. And this time it gives us an easier way, right? Because the first two digits you see are already larger than 40, which means that how many times can the dividend, which is outside, go into the divisor inside? And we only focus on the left two numbers first of the inside number. So let's see 45. Well, 40 can only go inside one time, right? So we put a 1 over here first, and then we subtract 40. And then what's 45 minus 40? Well, that's just 5, right? And then we drag down the 3 to make it 53. And since 53 is still greater than 40, we can divide one more time. 40 goes into 53 exactly one time, so we put 1 here and subtract 40 again. And this gives us the remainder of 13, which means that the final answer is going to be 11 with remainder 13. And that's your answer for number 3. And finally, problem 4 with the largest numbers, 785 divided by 62. Again, we can start dividing using the left two numbers, the leftmost numbers of the number inside, 78. How many times does 62 go inside 78? Well, that's really easy, right? It's just 1. And then we subtract 62. 78 minus 62 is 16. And since 16 is smaller than 62, we have to drop down the 5. So we drop down the 5 over here. And then this time, how many times does 62 go into 165? 2 times, right? Because you multiply 62 by 2 and you get 124. And then we have to subtract 124 by 165. And what do you get? 41. And since 41 is smaller than 62, we know that the remainder must be 41. The final answer is 12 with remainder 41. And that is how you do problem one as a whole. Moving on to problem two, where it says 275 oranges need to be packed into baskets. If each basket holds 30 oranges, how many full baskets are needed? And another problem, how many oranges will be left over? So we are given that each basket has 30 oranges or needs to have 30 oranges per basket, per basket. And the total number of oranges that we're working with is 275, which means that shouldn't we just divide 30 by 275? And this is the problem that we're working with. Well, let's see. What is the closest multiple of 30 that we can get to 275? It would just be 270, right? Because 30 times 9 would give us 270, right? So if it's 9, then we drop down 270, which gives us a remainder of 5 oranges. Which means that if we have 9 sets of 30 oranges, then how many full baskets are needed? 9 baskets with 5 oranges left over. And this is the answer to problem 2. Problem 3. Miss Jang handed out 12 pencils to each of her 25 students. Keyword, each. She still had 10 pencils left. How many pencils did she have originally? So this would be a multiplication problem, right? Because to each of her 25 students, each of the students got 12 pencils. So all we have to do is just multiply 25 by 12, right? So 25 times 12. We can again do the vertical method. So let's multiply the right-hand side first. 5 times 2 is 10. So we carry over the 1 here. And then we multiply diagonally 2 times 2 plus the 1 that we carried over. This gives us 5. And then we add 0 here as a placeholder. And we divide diagonally 5 times 1, which gives us 5. And then vertically 2 times 1 is 2. Add this together, 300. But it also says that she has 10 pencils left, which means that after giving 300 pencils to all of her students, she still had 10 pencils left. So all we have to do is add the 10 pencils to 300, which gives us 300 pencils in total. And this is how much she had originally. Problem 4. For the 4-digit number blank blank 42, how many possible digits can be placed in the box so that the blank blank 42 divided by 25 gives you a 2-digit quotient? So let's see here first. How do we set up this problem? Well, let's do blank blank 42. Put this inside the division bracket, and then put 25 outside. And this is how we set the problem up first. So let's plug in some numbers first here, right? Well, we know that the leftmost number matters the most because that is going to determine just how large the number is going to be, right? So let's start off with a number like 3. Well, let's do 3, and the smallest number that can go inside here to make the smallest 4-digit number that has 3 in, in its leftmost column. So 3042. So let's just do the smallest 4-digit number dividend here. Well, we see here that 25 goes into 30 one time. So we subtract 25 and we have a 5 left over, drag down the 4. And how many times does 25 go into 54? Well, 2 times, right? So 2 times 25 is 50. And then 54 minus 50 is 4. And again, we drop down the 2. And then this time we see here that how many times does 25 go into 42? Well, one time. So it doesn't matter what the remainder is. We have already reached over a 2-digit quotient. This is now a 3-digit quotient, right? Because the whole number quotient of 3042 divided by 25 is 121. So that doesn't work. So we know that the number in the leftmost hand side of this unknown 4-digit number must be 2 or 1. Okay, so if it must be 2 or 1, then let's see. Let's try 2 now. So let's try 2, and let's try a number that goes along with 2. So you plug in another number, right? 2442. So let's try this out. Well, this time 225 cannot go into 24 because 24 is obviously smaller than 25. So how does this work? Well, this time we have to extend the number being divided by another number to the right, which means we have to divide 244 to 25. And what does this give us? Well, how many times does 25 go into 244? If you said 9, you're correct. 9, 225. And then this time we have to subtract. So what is 244 minus 225? The answer is 19. And then we can't, 25 can't go into 19, so this time we have to drop down the 2. 192. What's 192 divided by 25? We see here that the whole number component must be 7, right? Because 25 times 7 is 175. 175 here. Perfect. And then this time we know that there must be a remainder, right? But the remainder can't be larger than 25. So it's 17, right? Because 192 minus 175 is 17. And you notice something. This is, by the way, 2,442 is the largest number that you can get that when you divide it by 25, it gives you a two-digit quotient. So the final answer for 2,442 divided by 25 is going to be 97, remainder 17. So now we know that 2,442, I'm giving you guys this, is the largest four-digit number that can work. So what about all the other numbers that can work? Well, this time, you can just plug in whatever numbers, right? It's not that many. We know that all the ones can work because they're all smaller than this number right here, right? So if all the ones can work, then the number in front of the box is 1. And then the numbers from 0 to 9 can all work, which means that in total there are 10 combinations for a four-digit number that's starting with 1. And we know that for 2, it can only go up to 4, which means that if it starts with 2, then there's only 5 combinations. Which means that there's 15 possible four-digit numbers for this problem. 15 possible. And then now problem 2, which is the second part of this problem. In the division 4,325 divided by blank 0, what is the smallest digit that can be placed in the box to make the quotient a two-digit number? Let's set this problem up. 4,325 divided by blank 0. So the most logical choice first would be to 4, right? Because 4 is the largest number that can fit that would still go into 43 one time. So why not start with that? So let's carry over 1 here. 40 goes down here. 43 minus 40 is 3. And we drop down the 2. And you notice that 40 can't go into 32. So we just put a 0 at the top. And we drop down 5. 325 divided by 40, we realize that, hey, 40 goes into 325 8 times. And from here, we already know that it can't be 40. 40 is not the smallest digit because what we're given is a three-digit number, 108. There's still a remainder, but the whole number answer is 108, so that's obviously not correct. So let's try 5 this time. Would 5 work? Well, we'll see. We drew 5 this time. 5 cannot go into 43, obviously. So let's see here if we can go into 432. It does go into 432 8 times. So 400. And then we have to drop down a 32. And then, since we drop down to 32, and then we have to pull down the 5 from here, because that's the number that we have to pull down. How many times does 50 go into 325? Well, the answer would just be 6, right? Because 6 times 500 is 300, and we're left with a remainder of 25. So 5 is the smallest digit that can be placed in the box because it gives you a whole number answer of 86, but with a remainder of 25. So that's how you're going to do this answer. The answer is 5. And that is how you do number 2. Problem 5. How many three-digit numbers are divisible by 32? And what are the smallest and largest such numbers? So let's calculate the smallest number first. The smallest number is obviously going to be 128, right? Because 128, that's just 32 times 4, and that's the smallest three-digit number that is divisible by 32. Now, the larger number is going to be more difficult, but what we do know is that the largest three-digit number is 999. So how about we just divide 999 by 32, and whatever the remainder is, let's just subtract that from 999. So let's divide this by 32 first. And how many times does 32 go into 99? 3 times, right? Because 3 times 32 is 96. And then 39, we know that 32 goes into 39 one time, so 32, and the remainder is 7. So the remainder is 7, which means that the largest three-digit number that's divisible by 32 is going to be 992 because 999 minus 7 is 992. So we already solved one part of the problem, all the way to 992. But now we have to see how many numbers, inclusive of both 128 and 999, are in between these two numbers. In order to solve how many numbers are in between, let's subtract 992 to 128 first to solve the gap. And this would give us 864. 864 being the total amount between 128 and 992. And from here, we have to see just how many multiples are divisible by 32. How do we do this? Simple. We just divide 864 by 32. So 32 goes into 86 two times, 64, and then 22. And then we pull down the 4 here, 4 here. And then this time we have to solve 224 divided by 32. That just gives us 7, right? So you would think it's 27, but wrong, because when we subtract 992 minus 128, we are actually subtracting both of them. But we only have to subtract 1 because we're counting both twice, which means that we actually have to add back the 128 because 128 was not counted when we subtracted it from 992. So it's actually 27 plus 1 equals to 28 such numbers that are divisible by 32 in three-digit numbers. So the answer is 28. Problem 6. Find all two-digit numbers of the form blank 0 such that when 228 is divided by blank 0, the remainder is 28. So blank 0 is going to be a two-digit number, right? Two-digit number, and the ones place has to be a 0. So how do we approach this problem? Well, first we know that the remainder is 28. So let's make this problem more simple by removing a remainder. So how do we remove a remainder from a number such that it's exactly divisible? Well, simple. We just subtract it. 228 minus 28 equals to 200. So then blank 0, or the two-digit number of the form blank 0, should be exactly divisible by 200. Okay, so what are the possible solutions? Well, let's see here first. 10 could work, right? 10 because 10 is divisible by 200. 200 is a multiple of 10. 20 could also work, right? Because 20 times 10 is 200. But you see, well, 30 can't work, right? Because 30 is not divisible by 200, right? So that doesn't work. 40 works, right? Because 40 times 5 is 200. And so 50 also works. But beyond 50, we notice that there aren't any other solutions left. So therefore, these are the only 4 two-digit numbers that we can test out first. But quickly you realize something, is that 10 and 20 do not work. Why? Because it says that the remainder is 28. If the remainder is 28, then the remainder can't possibly be bigger than either of these solutions, because otherwise it would have added 1 to the other solution, right? Like a remainder cannot be bigger than these two numbers right here. So therefore, these don't work. So therefore, the only solutions that work are 40 and 50. And these two are going to be your solutions. Two solutions. Problem 7. Find the largest possible value of a such that a divided by 32 equals to 20 remainder b. Okay, so how do we solve this problem if we are given that b is also the remainder? Remember, if we want it to be the largest possible value of a that doesn't go over 20 when it's divided by 32, then we must know that when the remainder must be 1 unit less than what it's being divided by. Therefore, it must be, b must be 31 because that's the largest that a number can get without, adding another unit, adding another cycle to 20. So therefore, b must be 31. And we also know that if a divided by 32 is 20, then we just flip that. 20 times 32 must be a. And what is 32 times 20? Well, shortcut. Since 20 has a 0 in the ones place, all we have to do is multiply 32 by 2, which is 64, and then just drop down the 0. 640 plus 31 is just 671, which means that a, the largest value of a, is 671, where it can still satisfy the following condition here. Problem 8. Find the digits in the blank. This time, this problem is kind of hard, but it is still pretty much doable. So first thing that you will see is that the unit on top is 3. What does this mean? Well, since we know that there is two blanks here, we must know that the number here on top is larger than the 2 on the bottom. And the 2 on the bottom is always going to be the largest multiple of 16 that went into the top number in the red before, going down. So the bottom number is just 3 times 16, right? Because that's the largest multiple, 48. And we also know that this number must be 2, as I just write here, because it's dropped down here, right? It's literally dropped down. And if these two numbers here, as a result of subtraction, is 11, then the top number must be 59, right? Because 59 minus 48 is 11. Now, we can see here that since we've plugged in all these numbers, well, what next? Well, now, since we have 112 at the bottom, then we have to see, well, does that go into 16? Well, yes, it does, right? Because 16 times 7 is 112, which means that 16 times 7, 112, we drop that down here, and perfect. 112 minus 112 is 0. There's no remainder. Perfect. So the final answer is 592 divided by 16, which gives you 37. And you can confirm this by multiplying 37 by 16, and you will still get the same answer. 592. And there's also a second part to this problem. This time, the entire top row is blank, so we don't even know what the final quotient part is going to be. But what we do know is that this time the number on the left-hand side is given. The divisor is given. That's 23. So if it's 23, then what must be true? What must be true of this problem to get that? Well, first, it must be 40 something, right? So we know that 23 must go into this number some amount of times. But what we do know is that it cannot be less than 46. Why? Because if it's less than 46, then that means that 23 can only go into it one time. So if it can only go into it one time, then this number would be 23, right? But we notice that when we subtract the 40 something by 23, that is a number that is obviously going to be greater than 2, right? But since we're already given that 2 is going to be a number that is the result of subtracting 40 something by the number at the bottom, then the number must be something that lets 23 go into it 2 times. Immediately, we find that to be true, right? So it must be that the top number is 2 because 23 goes into 40 something 2 times. And what more could this be? We know that this number this time at the bottom must be 46 because 23 times 2 is 46, the largest multiple of 23 that goes into the 40 something at the top. And then from here, we quickly get that this number must be 8, right? Because 48 minus 46 is 2. And then now we've solved this. Well, let's see here. What's next? Well, this time we are given the number at the bottom is 20 something. We know that the only possible number that 23 can go into this number is 1, right? Because no matter what you put at the bottom, what you put on the right-hand side of 2, it's always going to be 20 something, which means that the largest number that it can be is going to be 1 at the top. So 1 times 23 is going to be 23, right? Because that's the multiple of 23 that you get when you multiply it by 1, which also means that the number in the blank must be 6, because 26 minus 23 gives you a remainder of 3. And then obviously we know that this must be 6 at the top because we dropped down the 6 here. So in total, the final answer is 486 divided by 23, which gives you 20, hold on a minute, 21 with a remainder of 3. And that is your final answer for this problem and what you filled in. Problem 9. Find the four-digit number of the form 7,600 and something 2 that is exactly divisible by 23, so it goes exactly into 23. Let's rewrite this problem. 7,600 and something divided by 23. Well, this starts off good, right? Because we know that 23 can go into 76 some number of times. So what's the closest number that we can get to 76? Well, that's just 69, right? So what is 69? 69 is basically 23 times 3. So we know that 3 is going to be the whole number on top of the quotient, and 69 is the largest multiple of 23 that we can get to. And then we subtract 76 from 69, which gives us 7. And now we have to drop down the unknown number here. And we have to see what number that when you fill up 70 gives you 23, right? But we understand that it doesn't have to go into 23 perfectly. This number right here, in fact, it can't because there's no multiple of 23 that starts with 7 and is a two-digit number. But what we do know is that the remainder of 70 something divided by 23 at least must equal to 9. And why must it equal to 9? Because this number must be exactly divisible. And 92 is divisible by 23 perfectly. So whatever the remainder is, whatever the quotient is, the remainder must be 9 so that when we drop down the 2 over here, it goes into it perfectly. So let's see if we can do that. Well, let's see here first. Let's imagine that it be, what's the closest number that it can get to 70 something? Well, the closest number that it can get to 70 something is 69, right? So again, we just put 3 at the top, and that would just be 69. But what number should go inside here? So 70 something minus 69 would give you 9. That would just be 8, right? It would just be 8 because 78 minus 69 is 9. And then 92 divided by 23, that would give you 4. So 334, that is the final answer. There is no remainder. That's exactly the final answer. So what is the four-digit number that this problem is looking for? That would just be 7,682. And why is it 8? Because remember, we pulled down the number here, and we found out that the number being pulled down to the bottom should be 8. Problem 10. A, B, and C are positive integers, satisfying that A divided by B is equivalent to C. So by the way, we can just rewrite this by saying B times C equals to A, right? It's the same thing. Given that A times B times C is 1600, determine the value of A. So right away, can we rewrite something? Can we rewrite B times C into A, right? Which means that A times A is 1600. And the only way to make this work, because remember, these two have to be equal, is if A equals to 40. And if A equals to 40, then we immediately rewrite this problem on the top by 40 divided by B equals to C. And the only way that we can possibly plug in numbers for B and C and multiply A, B, and C together to 1600 would be if we made B 20. B is 20, C is 2. This is logical, right? 40 divided by 20 equals to 2. And when we multiply 40 times 20 times 2, that gives us 1600. But it's only asking us to determine the value of A. So you technically didn't even have to do all of this. I'm just showing you guys that it's logical. A is equal to 40. That's what the problem was looking for. Problem 11. Find every two-digit integer, blank blank, such that dividing 54 by it leaves a remainder of 6. Well, what if we don't want the remainder? Because solving for a remainder is too difficult. Let's make it so that there is no remainder. So let's just subtract the remainder by the dividend, minus 6, minus 6. So we also subtract 6 from the dividend 54 to make it no remainder. And this gives us 48 divided by a two-digit number equals to a whole number. So what are the possible numbers? Well, the smallest one would obviously be 12, right? 12 because 48 divided by 12 would just be 4, so that works. And then the next number would be 16 because 48 divided by 16 is 3. 16, 3. And then what is the smallest next number? Well, that would just be 24 because 48 divided by 24 is 2. And then finally, we know that the last number must be 48 because 48 divided by itself would just be 1. That always works. So in total, there are 4 two-digit numbers that satisfy this equation: 12, 16, 24, and 48. Problem 12. Determine the greatest three-digit integer n for which the quotient obtained by dividing n by 34 equals the remainder. Do you guys understand what this problem is asking? The final answer and the remainder must be the same. Quotient equals to remainder. So let's solve this first. So we are given that the integer is n, right? And then we also note that this integer must be equal to 34 times the quotient, so Q for quotient, because the quotient must be able to multiply by 34, multiple of 34, right? And then plus the remainder. But if we already say that the quotient and remainder is the same, then can we technically just swap out R for Q? So we swap out R for Q, which means that N is equal to 34Q plus Q equals 35Q. In other words, the greatest three-digit integer N must be a multiple of 35. So now let's see what number satisfies that equation. The greatest three-digit number is 999. And let's divide that by 35. How many times does 35 go into 99? Well, that's just 2 times, right? 2 times 35 is 70. So we subtract 99 from 70. This gives us 29. And let's drop down the 9 here, which gives us 299. And let's divide 299 by 35. This just gives us 8. It goes into it 8 times here. And then 8 times 35, that's just 280. Remainder 19. So if the remainder is 19, then all we have to do is subtract 19 from 999, which gives us 980. So n is going to be 980, or in other words, the greatest three-digit number that when you divide it by 34, it gives you the quotient, which is the same as the remainder. But let's find this out first, right? Let's find out 980 divided by 34. Let's just see what the quotient is, right? Let's just see what the remainder is. 900 and how many times does 34 go into 98? Well, that would just be 2, right? Because 2 times 34, that is 68. And this would just be 30 carried down. And then we carry down the 3, we carry down the 0 here, which is 300. And then 300 and divided by 34, this would be 8 on top, 8 right here. And then 8 times 34, this would give us 272. And we see here that once we subtract it, it gives us a remainder of 28, which is the exact same as the quotient. And that's how you double check your answer. The correct answer is 980 for n. Problem 13. Find the digits in all the blank squares. So this time it's a bit harder of the previous problems that we did, right? But from here, all we have to do is simply just find clues. There's clues scattered all over this problem, with the most obvious one being the 6, right? The 6, which is dropped down, which, we always drop down, which means an immediate clue that this number here must also be 6. And if the remainder is 2, then that means that this number below the 6 must be 4. But what does this mean? Well, you see here that there's also a 9 on the top. Well, if there's a 9 on the top, then basically what this number is at the bottom is basically 9 times the divisor. And in order to get a 4 in the ones column of the product, then we know that this blank number must be 6. Why? Because if you multiply 56 by 9, that is the only time when you get a number with the ones digit as 4, 504. So that's immediately how you get this problem. And then from the top, we can also plug in that the top number is going to be 506, right? Because 506 minus 504 is 2. But how do we approach the next few empty boxes? We also know that this box must be 0 because 0 is being pulled down here, right? But remember, when we pull down something, we immediately have to divide it by the divisor again. But since you see here, 50 is smaller than 56, which means that when we pull it down and divide it, nothing goes in. There is not a single multiple of 56 that can go into 50, which means that the number on the top must also be 0. Okay, and now we are just left with 5 empty boxes left. How do we approach this problem? We know that since we are left with 2 digits, then the number on the top must immediately be 1. Why? Because there is no 2-digit number that can let 56 go inside it 2 times, right? Any 2-digit number can only let 56 in 1 time. And the top number obviously can't be 0, right? So it must be 1, which means that 1 times 56, which is 56, must be the number at the bottom here. And what number, when you subtract it by 56, gives you 5? That's just 61, right? Which means that the final answer is 6,106 divided by 56 gives you 109 with remainder 2. And you can also find the rest of the boxes filled here. Number 2 of this problem. This time it's a bit harder, but it's still doable. There is nothing given on the top this time. So how do we find out this problem? Well, again, we find out that the first 2 numbers here are 70 something. And we know that no matter what number we put after 70, 660 something can only go into it once. So immediately we know that the number here must be 1. And then 1 times what number gives you something 8? 68, right? 68. So 1 times 68 is 68. And then we already solved these 2 blank columns. And we also know something. This number, which I'm going to highlight in blue, times 68 must make up this number, right? Because it must be a multiple of 68. And the only way to make this happen with a single digit is if we put in 9 here, because 9 times 68 gives you 612. And if it gives you 612, then we know that the top number above 612 must be 615, because the remainder is 3. So let's plug in those numbers right now. 615. And from here, we quickly get that if this number here, which I'm going to highlight in green, is 6, then 74 minus 68 would give you 6. And then the following numbers are just as follows. We just pull down 1 from here, and we pull down 5 from here. And that is how you quickly get this answer. 7,415 divided by 68 would just give you 109. Because remember, when we divide 61 by 68, that doesn't go in, right? 68 cannot go into 61 even one time, so we just plug in the 0 over there. And this is how you get the answer, 109 with a remainder of 3 at the bottom. Problem 14. Find every positive integer a for which the numbers 196 and 227 leave the same non-zero remainder when divided by a. Since 227 minus 196, we understand that the gap between these two numbers, 227 minus 196, is 31. We understand that 31 must be divisible by a, because the gap between these two numbers makes it so that these numbers leave the same non-zero remainder when divided by a. So therefore, 31 must be divisible by a. And a can only be 31 or 1. But we can quickly eliminate 1 because it has to be a non-zero remainder, which means that a can only be 31. And let's just test this out. Let's see here, 196 divided by 31 first. How many times does 31 go into 196? That would be 6, right? Because 6 times 31 is 186. And the remainder would be 10. And let's see about 227. 227 divided by 31, which means how many times can 31 go into 227? We know that 31 times 7, that's the whole number component of this, times 31 is equivalent to 217, right? And if we subtract 227 from 217, we get that the remainder is again 10. Which means that yes, A is 31 because when we divide 31 from both these numbers, the remainder is the same. Problem 15. How many three-digit integers leave the same remainder 9 when divided by both 12 and 15? So let's let n be such a number that n minus 9 is divisible by both these numbers, 12 and 15. So this is why we have to find out the LCM, or least common multiple. And the least common multiple in this case is going to be 60, because 60 is divisible by both 12 and 15 exactly. And then we have to seek out all three-digit numbers that leave a remainder of 9 when divided by 60. So let's find the greatest three-digit number, 999. So let's divide 999 by 60 first. So let's divide this. 99 divided by 60, we get 160. 99 minus 60 is 39, so minus. And then we drop down the 9, right? We drop down the 9 right here. And then what is 399 divided by 60? Well, we get 6 here, and then 360 drop down to the bottom, remainder 39. So the answer is 16, remainder 39. And then the admissible numbers should run as follows. 60 times 2, right? Because 60 by itself, that is a two-digit number. So we have to multiply by 2 to get a multiple of 60. That gives us 120. But we have to add 9, right? Because the remainder of 9 equals to 129. This is the least admissible number because it is both three-digit number and it has a remainder of 9 when divided by 60. And then what is the most? Well, the most would just be 60 times 16, right? This is the closest that you can get to 999, and then plus 9 again because remainder equals to 969. So 969 is greatest admissible number. And now you have to find out just how many numbers are between 60 times 2 and 60 times 16. So in other words, how many numbers between 60 times 2 and then 60 times 3 all the way to 60 times 16? This would just be 16 minus 2, right? Minus 2 plus 1 because we have to add back the 1 when we subtract equals to 15 integers. So the answer is going to be 15 integers. Problem 16. In the following division, the dividend and the quotient are identical. Determine the remainder b if 208 divided by a equals to a with remainder b. We can rewrite this problem to remove the remainder by 208 minus b equals to a times a. But we have to find out first, well, what is a? Well, let's take 15 for example. If a were to be 15, then that would be 15 times 15, right? Equal to 225. 15 cannot work because 208 is less than 225. And 225 is already greater than 208. So how can we get to 228, 5 if we're already subtracting b? So then let's see that B cannot work. B cannot work. In addition, if A equals to 13, then 13 times 13 equals 169. And if it is 169, then we quickly figure out that B must be 39. B must be 39. But this is impossible because the remainder can never exceed the divisor. So therefore, this also cannot work, just like the last one. Now let's see 14. 14 is in the middle of them. If A equals to 14, and 14 times 14 equals to 196, then what would B be? Well, 208 minus 12 would get us 196, and this satisfies all equations. It's logical, it makes sense, and most importantly, the remainder, as we see here, the remainder b, which is 12, this is less than the divisor, which is good. Therefore, b, the remainder, equals 12, and a equals 14. And that's the solution to problem 16.